Welcome, grade 9. Today we'll discuss chapter 5, section 1, work. What's meant by work? Work means to do something that takes physical or mental effort. And this is an everyday sense of work because it is different from the scientific meaning of work. So, in our everyday sense, to do an effort means to do work. But this is not the case in the scientific meaning or in physics. In physics, or the scientific meaning of work means that a work done on an object when a force causes a displacement of an object. So, to do work, you need force and displacement. We can say that without force, there is no work done. And also, without displacement, there is no work done. Without force, if there is no force, there is no work, or the work equals zero. And this is logic. But the second part, which is different from the everyday sense, that there should be displacement. If the displacement equals zero, the work done equals zero. There is no work done. So, here the work equals force times displacement. The work done equals the force multiplied by displacement. If the force and displacement in the same direction. So now, if the force equals 0 and displacement, for example, equals 10, 0 times 10 equals 0. If the force equals million and the displacement equals 0, million times 0 equals 0, so the work equals 0. Clear? So the work equals force multiplied by displacement. Let's discuss an example. A student is carrying a school bag without moving. What's the work done in this case? He's doing work against the force of gravity. This is the direction of force. But without moving, displacement equals 0. So in this case, the work equals 0. Clear? So the work requires displacement. So we can define the work as the product. Product here means multiply or times. The product of force and displacement if they are in the same direction. For example, a force of 100 Newton acts on an object to move it 5 meters. Displacement equals 5 in its direction, in the direction of the force. What's the work done in this case? In this case, the work equals force, which is 100 Newton, multiplied by 5 meters, which is the displacement, equals 500 Newton times meter. Newton times meters times meter equal to joule. So the measuring unit of work is called joule, which is equivalent to Newton times meter. Clear, guys? Now, what's the case if the force is not in the direction of the displacement? There is an angle between the direction of the force and the direction of the displacement. Here, this angle is called theta. They are not parallel to each other. In this case, the force is resolved in two components, as we discussed before while discussing vectors, that this force can be resolved into F cosine theta and F sine theta. So the force now is resolved into two components, and the first component F cosine and the second component F sine. This force is called the parallel component because it's parallel to the displacement. And this component is the perpendicular component because it makes 90 degrees with the direction of displacement. Which one of them will do work? The parallel component or the perpendicular component? Which one in the direction of the displacement? The parallel component, F cosine theta. In this case, the work done equals the parallel component F cosine theta multiplied by displacement. Rearranging, the work equals F d multiplied by cosine theta. The work equals force multiplied by displacement multiplied by cosine theta, and theta is the angle between the direction of the force and the direction of displacement. Clear? Okay. In the figure shown, find the work done by the force. What's the work done in this case? You have 1 minute to solve this example. Yes. Okay. We have a force of 20 Newton, displacement equals 5 meters, and the angle between the direction of force and direction of displacement equals 30. So the work done equals F 20 Newton multiplied by d 5 meters multiplied by cosine the angle equals 30. In this case 20 times 5 equals 100, cosine theta square root of 3 over 2, so 50 root 3 joules, or the work done equals 86.6 joules. Clear, guys? Okay. Another example. How much work is done on a vacuum cleaner pulled 3 meters by a force of 50 Newton at angle, let's make it for example 60 degrees. So find the work now. You have 1 minute to solve this example. Okay. The work equals f d cosine theta again. What's the force here? Force equals 50 Newton multiplied by 3 meters multiplied by cosine the angle equals 60 degrees. So 50 times 3 equals 150, cosine theta equals half, so the answer will be 75 joules. Another example. In the figure, a force of 30 Newton acts on a moving object and the object moves 10 meters. This is, for example, like the force of kinetic friction. An object is moving to the right, and this force is the force of friction that stops the object after 10 meters. What's the work done in this case? Work equals, and you have 1 minute to answer. Work equals F, which equals to 30 Newton, D equals 10 meters, multiplied by the angle, cosine angle. Angle in this case equals 180 degrees. Cosine 180 equals negative 1. So in this case, the work done equals negative 300 joules. Oh, the sign of the work may be negative. And we discussed before that the work done here is positive. So the sign of work may be positive or negative, depending on the angle. So the sign of work can be positive or can be negative. Can be positive if the force or its component, the parallel component I mean, in the same direction of the displacement. But if the force or its parallel component in opposite direction to the displacement, in this case the work done is negative. For example, the angle equals 180, or this is the displacement and this is the force. In this case, the parallel component will be in opposite direction to the displacement. So the work done is negative. When the angle is more than 90 and 270. If the angle between 90 and 270, the work done is negative. When the work is positive, we say that work is done on the object. Work is done on the object. While in the case of negative work, we say that work is done by the object on another object or anything else. Clear? I hope that you understand this lesson. Thanks a lot. Until we meet again.